and welcome to our Wednesday work. We're going to be taking a look at the green slides, this reading about earthquakes. And before you start reading, it's always a good idea to look at what is your purpose of reading. And our purpose for reading this today is to figure out how do earthquakes move through the earth. So earthquakes, we know that they shake things on the surface. You've probably seen videos. You've maybe seen things on the news when earthquakes have hit. But how does that work? What makes it shake? So that's what we're going to take a look at today. And our goal is to highlight anything to talk about that question. So that question, how do earthquakes move through the earth? So we're going to highlight as we go. And then we should be thinking about what are we going to do as a quick write over here about what we've learned. So I'm going to start. And anytime I start reading, I have learned that even though I feel like it might be faster to just start reading or search for answers. One of the things I've learned in some classes I've taken about reading to learn in science is that we have the pictures here for a reason. So I always do a picture walk before I read, and I have to force myself to do that. I do recommend it to you, even though I've been doing this for a long time. I went through 8th grade and I would skip the pictures. And now that I read by looking at the pictures, I understand a lot more. So when I look at these pictures, they're pictures of the different waves of the earthquakes. And I'm going to look into this. So when it says body waves, and it looks like there's two types of body waves, P waves and S waves. If we look at it, it appears P waves move the surface up and down, because look at that arrow. And it looks like it's kind of compressing things, because look at how those layers are squished together there. And then we've got S waves, which looks like it's going side to side. So P waves are kind of pushing through the earth. S waves are going side to side. And then I see surface waves here, and this looks to be waves on the surface of the earth going side to side. And then I'm going to look at, and I have to look a little closer because it's pretty tiny on my screen. The captions say P waves push particles forward and back as they travel from inside the earth to its surface. S waves travel in the same direction as P waves as they move side to side. So these two are inside the earth, the waves start, and then the surface waves happen on the surface of the earth, which kind of works because that's their name. Okay, after I've looked at this, now I have a picture in my head, which is very important to have that idea. What does this look like? And now I'm going to read. It says, when a piece of earth shifts suddenly, the energy of the earthquake moves out in all directions like a wave, like sound moving in all directions when a bell is rung. So I'm going to highlight this. And we're going to watch a video, or you just watched a video that showed the P waves and S waves moving just in one direction. A better model would have multiple slinkies going in multiple directions, but that's one thing that's, models sometimes have faults, and that is a fault of this model. So it does move, earthquake waves move in all directions as they are leaving where the earthquake starts. Like sound waves, earthquake waves are energy moving through matter. In fact, a P wave is just like a sound wave. So we're kind of getting into that idea of different types of waves here. Both waves push particles together and then pull them apart. So I'm going to kind of highlight P wave so I see it. And then I'm going to do this part. Push particles together and pull them apart. And I would tell you, I'm kind of peeking at what I highlighted the other time I read this, and I highlighted different stuff, and that's okay. That's why we call them push and pull waves. A P wave travels parallel to the direction in which it pushes the particles. So I'm going to do this. Push and pull waves, I think, is important. It's just really handy that they named them like that the push and pull waves are called P waves, which is nice. A P wave travels parallel to the direction in which it pushes the particles. Another type of earthquake wave, an S wave, also moves particles in the Earth's crust. But an S wave moves particles from side to side as it moves forward. And again, gosh, am I thankful that they called these the ones that make sense. So an S wave side to side even looks like an S, right? How they're moving, this does look like an S over here. The particles move in a direction perpendicular to the way the energy of the wave travels. That's why it's called a side-to-side wave. We're going to put that highlighted too. So P waves are being pushed. In the slinky, it was when he pushed it forward and they traveled all the way straight and then they came back. The S wave, when it went side to side, he took the slinky and moved it side to side, and it makes that S. In both cases, the energy is released by the sudden movement of a piece of Earth's crust, moves through Earth's particles, shaking them. So I'm going to put both, I'm going to highlight this, and I said it kind of funny, so let me re-say it. It says, the energy released by the sudden movement of a piece of Earth's crust moves through Earth's particles, shaking them. But when the wave has passed, the particles come back to rest in their original position. Your spring model showed this when the pieces of tape returned to their original positions, or when the slinky stopped moving. We didn't have tape on the one that we saw. This happens because energy moves through matter, transferred by waves. So we're going to learn about energy transfer and transformation at the end of the quarter. And it just means that we're moving the energy from place to place. And that's what energy transfer is. Together, P and S waves are called body waves because their energy travels through the body of the Earth. So we call those body waves, it goes through the body of the Earth. And you know what? When I'm thinking about this, I'm going to kind of put a thought bubble over here. I'm going to say, body of the Earth is inside. I'm having a hard time typing here today. My fingers were on the wrong spot. S-I-D. Body of the Earth is inside, under the surface. I feel like I might need to make the text in the other bubbles smaller. Okay, so I'm going to put that there. I don't want to cover up any of the text, but I want it in this area here. When P waves and S waves reach the surface, the energy spreads through the Earth's surface, shaking the particles from side to side. These are surface waves. So I'm going to go here. This one almost is that whole part, which makes me a little bit worried that I highlighted too much. But when we have this small of a text, they're really going to do a good job packing some of our ideas in. But P and S waves that reach the surface are called surface waves. So I think I have my stuff highlighted the way I'd like it. What I kind of want to do, though, when I'm looking at this, my eyes are not pulled to the P waves and the S waves. So what I might do is I might go back and highlight P waves and S waves, maybe a different color. And I might decide to make this P wave stuff that I highlighted, I might make this all blue because this is all about one type of wave. And you don't have to. I might make this S wave stuff. What color can I make the S wave? I did blue. Maybe I'll make this one purple. That's hard to read. I'm not going to do that. I made it hard to read. But and we'll just make that lighter purple. There we go. And I'm going to make this stuff instead of yellow because now I can see that the S wave and the P wave, that'll pull out a little bit better. And then I'm going to make surface waves maybe green so that I have a little bit different. So like, look at that. I can kind of see a little bit better. So what you should do right now is you should do your quick write. What do you notice? And then work your way down to the questions. And your highlighting should really, really help you with the questions. So probably if I were thinking about what I would write here for my quick write, I might just say, I might do 3 kinds of waves, P waves, push, S waves, side to side, and then surface waves on surface. And then I might put over here inside Earth and maybe inside Earth. And I think that that's basically what they talked about. There are 3 kinds of waves. There's P waves, which push, and they happen inside the Earth. S waves go side to side, also inside the Earth. And then surface waves happen on the surface. Not too complicated, very quick to write, but thank you for joining me. If you have any questions, please ask.